Hello everyone, welcome back. Let's talk about another easy problem on LeetCode today. String matching in an array, LeetCode 1408. In this problem, we are given array of string words and we have to return all strings in words that is a substring of another word. We can return the answer in any order. A substring is a contiguous sequence of characters within a string. Then in example 1, we start with words mass and check if mass is a substring of any other word in the list and the answer is no. So we move on to the next word as, and as is substring of mass. So we will add as to our answer list and move on to next word hero, and hero is a substring of superhero. So we will add hero to our answer list as well. And finally we check the word superhero, and as it is not a substring of any other word in the list, we will skip it. So finally our answer list will contain the words as and hero, and since the order of the string in the output list doesn't matter, even hero and as is a valid answer. Now in terms of solution, one of the naive approach can be what we did in example walkthrough. This problem, though easy, provides us an opportunity to practice fundamental looping structures and string comparison operations. And here is how we will solve it. We will iterate through each word in the list of words, say with iterator I, and then for each word we check if it is a substring of any other word in the list by using another iterator j, such that I is not equal to j, because each string is technically a substring of itself, and if we find a substring, we add it to our answer list. Let's now quickly go through the code. First, let's initialize an empty list answer to store the matching substrings. Then we will iterate through words array using iterator I, and inside the first loop we will start another loop to iterate through each word in the words array using iterator j. This allows us to compare each word with every other word. And first condition we check is if I is not equal to j, because technically a word is substring of itself. So checking for this condition avoids comparison of word with itself. And then we check if the word at index I is a substring of word at index j. If it is, then we will add it to our answer list and break out of the inner loop. Since we have determined that word at index I is a valid substring, there is no need to continue checking for other words. And finally, after both the loops have completed, we will return our answer. Now let's submit this code. Cool. Now in terms of time complexity, it will be O of n square into L square, where n is number of words and L is the average length of word in words array. Because first we run two nested loops resulting in time complexity of O of n square, and then we use the contains method, which takes O of L1 into L2 time, where L1 and L2 is length of two words. Assuming the average length of the words is L, this time complexity becomes O of L square. So overall time complexity becomes O of n square into L square. And in terms of space complexity, it will be O of n for storing the result list. So the bottleneck of this brute force approach is this contains method. And this is where algorithms like KMP, that is Knuth-Morris spread, and Rabin-Karp algorithms shine. These algorithms reduce the time complexity of contains method to O of L1 plus L2, which in turn reduces the overall time complexity to O of n square into L. I haven't covered these algorithms yet on the channel, but I will try to cover them in the coming days. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.